Now let's understand Python Dockerfile and compare it with the Node.js Dockerfile. Python doesn't build a binary. Here we build a virtual environment to keep the final image clean of compilers. Here is a Dockerfile of a Python application. It also has multi-stage build, that is stage 1 builder, stage 2 runtime, stage 1 builder. Here base image is Python 3.11 Slim, which is lightweight Python image. Installing build tools. Build Essential provides compilers and libraries needed to build Python packages with native extensions, that is NumPy, Pandas, SciPy. So Build Essentials provide the compilers and libraries that are needed to build Python packages with native extensions. Virtual environment. This creates V environment at opt/vnv so dependencies are isolated. Path update. This ensures that vnv's binaries are used instead of systems Python. Copy requirements. This brings requirements.txt. Install dependencies. This installs all Python packages into the VNV without caching to reduce image size. So this stage is only for building dependencies. It won't be the part of the final runtime image. So it's same like it has a builder stage and it has a runtime environment stage. Stage 2, that is base image. Again, this starts from Python. This starts fresh from Python 3.11 Slim. There are no build tools here. Copy the VNV. This brings the pre-built virtual environment from the builder stage. This is same as the previous Node.js one. Here we copy the pre-built virtual environment from the previous stage or the builder stage. Means we only take the required artifacts from the previous stage, so the image is lean and lightweight. Path update. This ensures runtime uses VNV packages. Copy application code. This copies projects files into the /app. Set working directory. /app becomes the default directory. Default command. This runs Python app.py when the container starts. So this stage is clean and lightweight. It only contains Python, the application and the dependencies. No compilers or build tools remain. So the image is lightweight. Let's compare it with the Node.js Dockerfile approach. What's same between them? Multi-stage build. Both are split into the builder and runtime stages to keep the final image slim. Base image choice. This starts with language runtime. For example, in Node.js approach, we have used Node 18 and in Python we have used 3.11 Slim. Dependency installation in builder, which is in Node we have used npm install for dependency installation in the builder stage, whereas in Python we have used pip install inside a virtual environment. That means npm install is for Node and pip install is for Python. Copying build artifacts. In Node we copy the whole /app directory. In Python we copy the virtual environment, that is /opt/vnv and the app code. Runtime stage is minimal. No compilers, only the language runtime plus dependencies plus app code. CMD defines the default process. For example, in Node, as I mentioned, node server.js would mean that when we run our application locally, we use this command node server.js. So the application would run on port 3000. It's same in the Python. Instead of server.js, node server.js, we use Python app.py to do the same what CMD does in node server.js. What's different between these Node.js and Python Dockerfile? The concept of dependency manager. In Node.js we use npm or yarn. In Python we use pip dependency file. In Node.js we have package.json or package log.json, whereas in Python we have requirements.txt. Build tools. In Node.js usually not needed unless native modules. Python explicitly installs build essentials for compiling C extensions. Isolation. Node modules live in the node underscore modules, whereas in Python dependencies installed into a VNV, that is /opt/vnv. Runtime copy. This copies application plus node modules in Python. This copies application plus virtual environment. Execution command, that is node server.js node and Python app.py in Python. Summary of Python Dockerfile. So Python Dockerfile is doing the same job as node, but in stage 1, that is npm install in node. In Python, it is pip install into a virtual environment. In stage 2, slim runtime, that is node 18 slim. Python uses 3.11 slim. Instead of node modules, Python has VNV directory that gets copied over. So both Node.js and Python are similar also because they are both interpreter language type, whereas the languages we discuss later are compiled. That would be a slightly different concept.